On this next one, we're being asked to find the average rate of change without being given the graph. So basically, we have to find the 2 points that go together. So I'm going to start by realizing that I need to find the point that has x equals 1 in it. So I know I have the point 1 comma something. And to figure out that 1 comma something, that means we need to plug in 1 into the function. So it'll be t of 1 is equal to 2 to the 1 minus 3. So in other words, I'm going to put 1 into the function, which means every x gets replaced with a 1. And so the end result of this is 2 to the first is 2 minus 3, which 2 minus 3 is negative 1. So that allows me to figure out that this first point was 1, negative 1, which basically came from plugging that in. How about I just put it down here? So I plug in the point, so I get 1 comma negative 1. So that's the first point, x1, x1, y1. And then the second point they asked me to find is when x equals 5. So that's going to be 5 comma something, so x is 5, and I just got to plug that in now to the function. So this will be t of 5 equals 2 to the 5th minus 3. So in other words, I'm plugging 5 into the function, and so every x gets replaced with a 5. So 2 to the 5th means 2 times 2 times 2 times 2 times 2. And you can do this with a calculator if you need some help, but let's try it together. So 2 times 2 to start with is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. So this basically is 32 minus 3. You could have used a calculator to verify that, but you end up with 29 for the y value on this one. So we could have done 2 to the 5th minus 3, and you can see how it's 29. So this equals 29, and the point that I have for y2 or x2, y2 would be 5 comma 29. And for the average rate of change, that's just how much change x over y. So that's the slope, which is m is equal to y2 minus y1 over x2 minus x1. And so we just need to plug in the appropriate blank. So 29 minus negative 1 all over x2, which is 5, minus x1, which is 1. And minus and negative means plus, so 29 plus 1 would be 30. And 5 minus 1 is 4. That does reduce a little bit to 15 over 2. So the average rate of change for this one is 15 over 2. All right, in the next one it says, what is the average rate of change of the function shown in the graph below from x equals negative 3 to x equals 4? Well, let's see if they can see it in the graph. First, this is the piecewise function. You can see it kind of goes up, levels off, comes down. That's what this would look like as a graph. So when x equals negative 3, it looks like it's just the point negative 3, 0. And that would come from the fact that you'd use the top function, because whenever x is less than negative 2, you're supposed to use the top function, and we're trying to evaluate x equals negative 3, and negative 3 plus 3 is in fact 0. All right, the second point, when x equals 4, again is nice, it fits on the graph, it's right there. It's the point 4, negative 2. Again, 4, just you can see, would be this bottom function, and negative 4 plus 2 is negative 2. But once we have those, we can just go to finding slope, which is the average rate of change, which is y2 minus y1 over x2 minus x1, which in this case would be negative 2 minus 0 over x2, which is 4, minus negative 3. And so the end result of this would be negative 2 over 7. And so it's basically going downhill, negative 2 over 7. That's correct. All right, which linear function below is increasing at the fastest, and which has the slowest rate? All right, the steeper it is, the faster it goes. So if you can kind of look at each rate, let's even write down the slope of each of these, because these are just linear equations. All it requires is that we find 2 lattice points. So if I find a lattice point there and there, this one has a rise of 1 over 3. And it looks like it's the slowest, but let's try each of these. Again, all I got to do is try to find 2 lattice points. So it looks like I got a lattice point there and there. So this one's increasing. Let me draw that like this. This one's increasing by a factor. It's going up by, what, 4 and over 1. So this one has a slope of 4 over 1. So that's got 4. And this last one, again, you're just looking for 2 lattice points. This one looks like it goes up 2 and over 1. So in this case, the slowest would be this one, and the fastest would be this one here. Fastest rate of change, and that one would be in between those two. It says, given the partial set of values of a linear function f of x and g of x, which function has the greater rate of change? So really we're just kind of looking at how the x's and the y's change. So as x goes up by 1 on this first one, y goes up by 2. And so the rate of change on this first graph is m equals 2 over 1, because it's the change in y over the change in x. And if you look at that, that's basically the change in y, and all these are consistent. It's 2 over 1. Now if you look at the bottom one, it is going up by 5 on the bottom each time. And the x is going up by 2 each time. And so the rate of change for this one would be 5 over 2. So it's really close. Again, you got to put the change in y on top over the change in x on bottom. And so this one would be 2.5. So the one on the bottom is a little bit faster. So g of x is a little faster, or has a greater rate of change, I should say. Has a greater rate of change. So for every x jumping 2, it's just, again, its slope. It's 5 over 2 on this one. All right, given the partial set of values of exponential functions, f of x and g of x, which function has the greater rate of change for all x greater than or equal to 0? So it's the same concept again. We're kind of looking at which one jumps faster. So as I go from 0 to 1, this one goes up by 2. And on the bottom function below, as I go up from 0 to 1, that one goes up by 1, but this one only goes up by 1. So it looks like the top function is going to win on this one. And you can try it with all these, but the difference between these two is linear is always going to be constant, and exponential is always going to be changing. So as I go up again by 1 on the x this time, from negative 3 to 3 is up by 6. So it moved a lot faster. And let's try this one again. From 1 to 2 it went up by 1, but from 5 to 7 it only went up by 2. So it seems like this one is, the blue one is always just a little bit faster than the green one. All right, let's try from 2 to 3. From 2 to 3, again, it went up by 1, and from 3 to 7, it went up by 18. And as this one goes from 2 to 3, again, the x went up by 1, but the y went up from 7 to 11, that went up by 4. And so you can see up here, this one's jumping much faster. It jumped by 2, then by 6, then by 18. And so this is a much more accelerated rate. So in this example, I would say that p of x has a greater rate. All right, the last one. Consider the linear function f of x equals x squared minus 2 and g of x equals 2 to the x minus 3. Which function has a greater average rate of change from x equals 1 to x equals 3? All right, so this is just basically doing this twice. So first we're going to start with the point 1 and plug it into the first function. And then we're going to also have the point 3 and plug that into the function and then find the slope. So for this one, I have f of 1 is equal to 1 squared minus 2. So the end result of this would be basically 1 minus 2, which is negative 1. So I have the point 1, negative 1, and that's for the f function. Let's try the second point. I also need to do the point f of 3 equals 3 squared minus 2. So the end result of this one would be 9 minus 2, which is 7. And then all I'm going to do is find slope for this first function. So m is equal to y2 minus y1 over x2 minus x1. So this would be 7 minus negative 1 all over 3 minus 1. And the result, 7 plus 1 is basically 8. 3 minus 1 is 2. So the rate of change, average rate of change over these x equals 1 to x equals 3 would be 4 for the first function. Now we're going to do the same thing again, but for the second function. So we'll do 1 comma and then something, and then 3 comma something because it's x equals 1 to 3. So I did 1 to 3, and now I'm going to plug each of those in. So this will be f of 1 is equal to 2 to the first minus 3. You can see right here I just plugged in 1 for the x. So if I do that, 2 to the first is just 2, and 2 minus 3 is equal to negative 1. So that's negative 1. And I try to plug in the next function, so I'll do f of 3 equals 2 to the 3 minus 3. So let me plug in the 3. Alright, so 2 to the 3, or 2 to the third, is 2 times 2 times 2, which is 8. And 8 minus 3 is 5. So that helped me determine that this one was 5. And now I just got to find the slope of that one, which again would be y2 minus y1, which is negative 1, all over x2, which is 3, minus x1, which is 1. Okay, so this will end up being 5 plus 1, which is 6, and 3 minus 1, which is 2, so the rate of change is 3 for this one, so it looks like f of x is has the greater average rate of change. So let me see if I make this a little smaller so I have enough room to state that. So f of x has a greater average rate of change. I hope this was helpful, and good luck on your quiz. Please ask your teacher if you have any additional questions.